Hello everyone. In this review session, we are going to look at pure one integration. What is integration? The fundamental theorem of calculus states that integration is the inverse process of differentiation. Suppose you are having a function y and you are differentiating it, you will get dy by dx. Okay? If you integrate this function dy by dx, you'll get back the function y. Okay? Let us take y is equal to x power n plus 1 divided by n plus 1, where n is not equal to negative 1. Then what is dy by dx? Dy by dx equal to n plus 1 multiplied by x power n divided by n plus 1. This n plus 1 and n plus 1 gets cancelled. So you will get dy by dx equal to x power n. So when dy by dx is x power n, we can say y is equal to x power n plus 1 divided by n plus 1 plus c, where c is a constant. Okay. So this can be written as x power n. If you are integrating x power n with respect to x, you will get x power n plus 1 divided by n plus 1 plus c, where c is an integration constant and n is not equal to negative 1. Okay. Integral x power n dx is called as indefinite integral of x power n with respect to x. Why we are calling it as indefinite integral? Because it has infinitely many solutions. Okay. Let's look at this example. How to integrate x cube with respect to x. Integral x cube dx equal to increase the power of x by 1. So 3 will become 4 divided by the new power, that is 4 plus c. Okay. So this is our formula. Let's look into some of the formulas we need to follow while integrating. Rule for integrating constant multiples of a function. Integral k f of x dx equal to k multiplied by f of x dx. Okay. For example, suppose we have integral 3 over x cube dx. Okay. Now take out the number 3, the constant. So 1 over x cube can be written as x power negative 3 dx. Okay. Now let's integrate this one. X power minus 3 can be integrated as x power minus 2 because we are increasing the power of x by 1. So x power minus 2 divided by minus 2 plus c. So minus 3 over 2x square plus c. Okay. So what's the next rule? Rule for integrating sums and differences of two functions. So f of x plus or minus g of x dx. If you are integrating two function, addition of two function or subtraction, then it can be written as integral f of x dx plus or minus integral g of x dx. Okay, let us look into this example for this x square plus 2x dx. Okay, so this can be written as integral x square dx plus 2 integral x dx. Okay, so how to integrate this one? Increase the power of x by 1. So x cube divided by 3 divided by the new power plus 2 integral x gives x square divided by 2 plus the constant c. Okay, so x cube divided by 3 plus x square plus c. Let us look at another example. This one is from the paper May June 2003. Find integral 4x plus 6 over x square dx. How to integrate this one? This can be written as 4 integral x dx plus 6 multiplied by integral x 1 over x square can be written as x power minus 2 dx. Okay, so 4 increase the power of x by 1, so x square divided by 2 plus 6 x power negative 1 divided by negative 1 plus c. This is equal to 2x square minus 6 divided by x plus c. Next, reverse chain rule. How to integrate if the function is of the form ax plus b the whole power n. This is the formula ax plus b the whole power n plus 1 divided by n plus 1 multiplied by 1 over a, that is the coefficient of x, okay, plus c. Let's see an example for this. Integral 2x minus 3 the whole power 4 dx. Write the base, that is 2x minus 3. Increase the power by 1, so 5, divided by the new power. Then write the coefficient of x in the denominator, which is 2 plus c. So 1 over 10 multiplied by 2x minus 3 the whole power 5 plus c. Now let us see one example, one more example. This is from the paper 12 ON 13. Find integral 2 divided by square root of 5x minus 6 dx. Okay, how to integrate this one? First, let us rewrite this given function as 2 integral 5x minus 6 the whole power negative 1 over 2 dx. This is equal to 2 multiplied by the base, which is 5x minus 6. Increase the power by 1. So you'll get 1 over 2. The whole thing divided by 1 over 2. In the denominator, write the coefficient of x, which is 5 here. Plus c. Okay, so this is equal to 4 divided by 5 square root of 5x minus 6 plus c. Okay, next, finding constant of integration. So far we have seen the integration which has the constant c. Now let us see how to find out the constant c. Okay, a curve is such that dy by dx equal to 8 divided by 5 minus 2x the whole power 2. Given that the curve passes through 2, 7, find the equation of the curve. Okay, so here the gradient of the function is given, that is dy by dx, and one coordinate of a point on a curve is given. Okay, first integrate the given gradient function, and next, to find the constant of integration c, substitute the given coordinate points. Now plug in the value of c in the integrated function to get the equation of the curve. Okay, so first let us write what is dy by dx, which is 8 divided by 5 minus 2x the whole square. And this one is from the paper 12 MJ 2016. Okay, so now integrate this one, you will get y is equal to 8 integral 5 minus 2x the whole power minus 2 multiplied by dx equal to 8 multiplied by 5 minus 2x the whole power minus 1 divided by minus 1 multiplied by the coefficient of x, which is negative 2 here, plus c. So y is equal to 4 divided by 5 minus 2x plus c. Okay, so the coordinate point is given as 2, 7. Substitute here, you will get 7 is equal to 4 divided by 5 minus 2 multiplied by 2. So 4 divided by 5 minus 4, which is 1. So 4 divided by 1 gives 4. 7 minus 4 will be 3. So this gives c is equal to 7 minus 3, which is 7 minus 4, which is equal to 3. So the equation of the curve is y is equal to 4 divided by 5 minus 2x plus 3. Okay, these are some of the question from the recent past paper. Okay, to find the constant of integration and finding the equation of the curve. Okay, similar question, you try these by yourself. The next topic in integration is definite integration. We can integrate a function between two specified limits. Okay, So I'll write now integral of the function x square with respect to x between the limit x equal to 1 and x equal to 3 as integral 1 3 x square dx. Okay, how to integrate this one? You will get x cube divided by 3 plus c. Okay, the limits are 1 to 3. First you need to apply the upper limit, then you have to apply the lower limit. Upper limit is 3 cube divided by 3 plus c minus of the lower limit, that is 1 cube divided by 3 minus c. The c and the c gets cancelled, and on simplification you will get 9 minus 1 over 3, which is 26 divided by 3. Okay, note that here the c gets cancelled. Okay, so integral 1 to 3 x square dx. This is called as definite integral. Okay, so integral a to b f of x dx equal to capital F of x, and the limit is a to b. So first you need to substitute the upper limit b, then minus the lower limit. Okay, so let's look at this one. Integral a to b f of x dx plus integral b to c f of x dx. We can combine these two integration into a single integration, integral a to c. Okay, see, in both the cases it is f of x only, and the limit is from a to b and here from b to c. Okay, so combinedly it is from a to c. So we are getting a and c here. Okay, so the next one is this one, integral a to b f of x dx. You can change the order of the limits by putting a negative sign. Okay, so here the lower limit is a, upper limit is b, and here we are interchanging the position of the lower and the upper limit. So we get negative integral b to a f of x dx. Okay, let's look at one more example. Integral 1 to 2 6 x square minus 1 over x square dx. So how to integrate this one? 6x cube divided by 3 minus x power minus 2. So x power minus 1 divided by minus 1, and the limit is 1 to 2. 6 over 3 gives 2 multiplied by the upper limit is 2. So 2 cube minus into minus, it will become plus 2 power minus 1. We can write it as 1 over 2. Then substitute the lower limit, minus 2 multiplied by 1 cube minus 1 over negative 1 also gives 1. Okay, on simplification this gives 13 and a half. Let's look at this example. This one is from the paper 11 ON 21. Integral 1 to infinity 1 divided by 3x minus 2 the whole power 3 over 2 dx. So how to integrate this one? Let us rewrite this as 1 to infinity 3x minus 2 the whole power negative 3 over 2 multiplied by dx. So 3x minus 2 the whole power negative 1 over 2 divided by negative 1 over 2 multiplied by the coefficient of x, which is 3 here. So the limit is 1 to infinity. Let's rearrange this integrated function. So we get negative 2 over 3 multiplied by 1 over 3x minus 2 the whole power 1 over 2, and the limit is 1 to infinity. So minus 2 over 3 multiplied by, when you substitute infinity for x, you'll get 1 over infinity. 1 over infinity is nothing but 0. Okay? Minus 1 over 3 multiplied by 1, the lower limit. 3 minus 2 is 1. So you'll get 1. So 2 over 3. Okay? So you have to remember 1 divided by infinity is 0. These are some of the other question. You can practice these. Okay? Definite integration question from the past paper. So the definite integral concept is used in finding area or volume of the given shape. Let us first look into this, how to find the area under the curve by definite integration. The first diagram shows the curve y is equal to f of x and the limits are a to b. The area under the curve within the limit a to b is given as integral a to b y dx. Okay, the area is enclosed by a curve on the x-axis in this case. So the next diagram, this represents the function x equal to f of y. Okay, so this shows the area enclosed by the curve x equal to f of y with the y-axis. Okay, and the limit is a to b. So the area under the curve, in this case the formula is integral a to b x dy. Okay, let's look at this example. This one is from the paper 12 MJ 2003. 2023. The diagram shows the curve with the equation y is equal to 10 x power 1 over 2 minus 5 over 2 x power 1 over 2, 3 x power 3 over 2 for x greater than 0. The curve meets the x-axis at the point 0, 0 and 4, 0. Find the area of the shaded region. Okay. The limits are given 0 and 4. Okay. And we need to find the area under the curve and the x-axis. The area enclosed between the curve and the x-axis. So what is the formula? The formula is integral a to b y dx. So area of the shaded region is integral a to b y dx. So the limit is 0 to 4 and y is 10 x power 1 over 2 minus 5 over 2 x power 3 over 2. Multiplied by dx. Okay, let us integrate this one. 10 x power 3 over 2 divided by 3 over 2 minus 5 over 2 multiplied by x power 5 over 2 divided by 5 over 2. The limit is 0 to 4. 10 divided by 3 over 2 gives 20 over 3. Let's substitute the upper limit. 4 power 3 over 2 minus 5 over 2 and 5 over 2 gets cancelled. So 4 power 5 over 2. Okay. On simplification, this expression gives 64 divided by 3. This is the area of this shaded region. Next, the area enclosed by a curve and a line or another curve. Okay. The diagram shows the curve with equation y is equal to x power 1 over 2 plus 4x power negative 1 over 2. The line y is equal to 5 intersects the curve at the point a of 1, 5 and b of 16, 5. Calculate the area of the shaded region. Okay. So here it is the area between a curve and a line. See, the curve is something like this one. Okay. And the line is like this. So when you find the area enclosed by the curve, that means you'll find this part. Okay. But actually we don't want this part. We want the area between the line and the curve. But when you find out the area under the curve, you will get this part. But when you find out area under the line, you will get this part. Okay. But we want only the shaded region, that is this part. Okay. So what we can do now is find the area enclosed by the line minus the area enclosed by the curve, so that you will get the shaded region. Okay. So the area is equal to Area of the shaded region. Area under the line minus area under the curve. Okay. What is the area under the line? What is the equation of the line? The equation of the line is y is equal to 5. So integral, and the limits are from here to here. Here it is 1. Here this is 16. So the limits are 1 to 16. Y is equal to 5. So 5 dx minus area under the curve is integral 1 to 16 x power 1 over 2 plus 4x power negative 1 over 2 dx. When you integrate the constant, it gives 5 multiplied by x. Limit is 1 to 16 minus x power 3 over 2 divided by 3 over 2 plus 4x power 1 over 2 divided by 1 over 2. The limit is 1 to 16. So you'll get 5 multiplied by 16 minus 5 minus the upper limit. Let's substitute the upper limit. 2 over 3 multiplied by 16 power 3 over 2 plus 4 divided by 1 over 2 gives 8. 8 power, okay, 8 multiplied by 16 power 1 over 2 minus the lower limit 2 over 3 multiplied by 1 power 3 over 2, which is 1 only, minus 8 multiplied by 1. So on simplification, this expression gives 9. So the area of the shaded region is 9. And this question is from the paper 13 MJ 2022. Okay. And these are the some of the area under the curve question from the recent past papers. The next topic is volume of revolution. So y is equal to f of x. It's a function. Okay. When an area bounded by the function f of x is rotated at 360 degree around the x-axis, a solid of revolution is formed like this. Okay. A volume of revolution is the volume of this solid formed. If you rotate it around the x-axis, you need to use the formula v is equal to pi integral a to b y square dx. Okay. And if you are going to find the volume of revolution around the y-axis, then this is the formula. Y is equal to f of x Try to make x as the subject and find out what is x square and substitute in this to use this formula. Okay, that is to find the volume of revolution around the y-axis. Okay, so area under the curve are finding the volume. Sometimes the answer may be required in an exact form. Okay, so especially in finding the volume of revolution, if the answer is required in an exact form, just leave in terms of pi only. Or if it is given like give the answer corrected to 2SF or 3SF like that. Okay, substitute the value for pi also and round it to 3SF. Okay. The next question. This is an example for finding the volume of revolution, and this one is from the paper 11 ON 2021. Question 10. The diagram shows the curve with equation y is equal to 1 over 3x minus 2 the whole power 3 over 2. The shaded region is bounded by the curve, the x-axis and the lines x equal to 1 and x equal to 2. The shaded region is rotated through 360° around the x-axis. Find the volume of revolution. So it is rotated about the x-axis. So you need to use the formula pi integral a to b y square dx. Okay. So the volume is pi integral. The lower limit is 1. Upper limit is 2. So what is the y value? 3x minus 2 the whole power 3 over 2. Bring it to the numerator. 3x minus 2 the whole power minus 3 over 2. Okay. So we need to write y square here. So the whole power 2 multiplied by dx. This 2 and this 2 gets cancelled. So pi, let us integrate this one. The base is 3x minus 2. Increase the power by 1. So negative 2 divided by negative 2 multiplied by the coefficient of x, which is 3. And the limit is 1 to 2. Okay. This is equal to minus pi over 6. Now substitute the upper limit 2. So 3 multiplied by 2 minus 2. It will be 4. 4 power minus 2. When you substitute the lower limit, you will get 3 minus 2, which is 1. 1 power negative 2. That is 1 only. Minus pi over 6 multiplied by 1 divided by 16 minus 1. 1 divided by 16 minus 1 will be minus 15 over 16. So minus multiplied by minus, it will give plus. So pi over 6 multiplied by 15 over 16. So this will be equal to 5 pi divided by 32. And these are some of the finding the volume question from the past paper. Try these questions. So under integration, we have seen how to find the equation of a curve, area under a curve, and volume of revolution. Okay. So around 8 to 11 marks questions will be asked in your paper 1. In 1 or 2 questions, and finding the equation of the curve and finding the area or the volume will be asked. Okay. Sometimes simple integration is also been asked, and you need to remember when you are integrating, and if the limit is infinity, and while substituting the limit, if you are getting 1 over infinity, the answer is 0. Okay. Hope this video is helpful to you.